Hello, in this video we will talk about problem E of Codeforces round 835 division 4. So the problem states that suppose you have a binary string of 1 0. So it defines a term which is inversion pair, and the definition of inversion pair is that there is a pair of indices, suppose I and j, and for this pair of indices if ai is greater than aj, then this pair is called inversion pair. Suppose if we choose I is equal to 1 and I is equal to j is equal to 2, so for this I is equal to 1 and j is equal to 2, ai is greater than aj, so we can see that this this 1 and 2, for 1 and 2 it makes a inversion pair. If we again choose index 1 and index 4, then again ai is greater than aj, so 1 comma 4 will make a inversion pair. So on this binary string you can do one operation, which is you can flip a particular index value, which is to say if a value of an index is 0 you can flip it to 1, or if the value of an index is 1 you can flip it to 0 by doing this. And you can do this operation at most one time. You are asked you are asked that by doing this operation, what is the maximum number of inversion pair you can get from a binary string. So let's take a test case. Suppose your binary string is 010010. First, let's calculate the number of inversion pair on this particular binary string. So this one will make inversion pair with this 0, and this 0. So there are 3, and this one will make inversion pair with only this 0. So there is 1. So there are 4 inversion pair present in this binary string before doing the operation. Now, if we change the if we change the first value to 1, then we get the number of inversion pair. For this one, it will make inversion pair with these 3 zeros. So there is 3. This one will make inversion pair with these 3 zeros. So there is 3. And this one will make inversion pair with only this 0. So there is 1. So there are 7 inversion pair you can make by flipping this 0 to 1. And by doing all possible, by choosing all possible index, you can see that this is the maximum you can get. So the answer here is 7 for the second test case. So let's dive into the solution part. So in the flip operation, you can do two things. You can change a 0 to 1 into 1, or you can change a 1 into 0. First, let's see if we change 0 to 1. So suppose this is your binary string, and for a particular index which is 0, you are changing this 0 into 1. So I would argue that it is optimal to choose leftmost 0, because whenever you are flipping a 0 into 1, two things happen. One is when you are flipping a 0 to 1, all the ones which were left to this 0 lose its one of its pair. So all the ones left to this 0 lose one of its pair. So suppose there is a 0 here and you are flipping it to 1, right? So all the ones which were present here, which which had made a pair with this 0, lose their pair, right? So it is optimal to choose the index as left as possible, because if you choose the index as left as possible, suppose you choose the 0 here, then the number of ones which lose their pair reduces. So if you choose as left as possible, the number of ones which will lose their pairs will get reduced. So it is optimal to choose the leftmost 0. So this is the first thing happen. Another thing that happens, which is whenever you are flipping a 0 into 1, you want that newly made 1 can have as more zeros on its right. So suppose here is your string and you are making this 0 into 1. So this newly made 1 can have inversion pairs with the zeros present here. But if you choose more leftmost index, suppose you choose this 0 to be 1, then this one newly made 1 can have more possibility of making inversion pairs, because more zeros will be present from this range to this range rather than this small range, right? So whenever you are flipping a 0 into 1, two things happens, and in both the cases we can see that it is optimal to choose the index as left as possible. Now whenever we are flipping from 1 to 0, let's see what happens. Here also two things happens. So suppose there is a particular 1 here and you flip it to 0. So what happens is this 1 earlier had made inversion pair with these zeros, but whenever you are making this 1 to 0, all the pairs this 1 had made earlier get lost. So it is optimal to choose the index as right as possible, because if you choose a, a more right index with 1 and flip it to 0, it will lose less inversion pair, because less amount of 0 will be present in this range and more zeros will be present in this range. So choosing this one is more optimal than choosing this one. So the optimal is, so this is the first thing that happens, which is the one which you have changed to 0 loses its inversion pairs. So it is optimal to choose the rightmost one, because if you choose the rightmost one, it will lose less amount of inversion pair. So optimal to choose rightmost one. This is the first thing that happens when you flip a 1 to 0. The second thing that happens, suppose you are flipping this 1 to 0, then what happens is the ones that are left to this newly made 0 make an inversion pair with these zeros. Suppose there are suppose there are ones present here, and these ones will make a new inversion pairs with this 0. So that's why you want this index to be as right as possible, because if you make this 1 to 0, only the ones present in this range can make an inversion pair. But this when you choose an index as right as possible, suppose you choose this index and flip it to 0, then the ones that are present from this to this range will make an inversion pair with this new limit 0, right? So you are letting more ones to make inversion pair with the new limit 0. So you are letting more ones to create inversion pair with this new limit zeros. So whenever you are flipping a 1 to 0, in both cases for A and B, you can see that it is more optimal to choose the rightmost one. So the solution of this problem is, first you will choose leftmost 0 and flip it to 1, or you can choose the rightmost 1 and flip it to 0. Let's call this operation A and this operation B. After doing this operation, you have to calculate the number of inversion pair, and after doing this operation, you have to calculate the number of inversion pair, and the answer is maximum of number of inversion pair without any operation, number of inversion pair without any operation, because we can do at most one operation. There may be some cases where you don't need to perform any operation, uh, and this may happen that performing operation may reduce the inversion pair also. So first we have to check what is the number of inversion pair without any operation. Then you have to check what is the number of inversion pair by doing operation A, and what is the number of pair by doing operation B, and the maximum of these three is the answer. So it is very easy to change the it is very easy to change the leftmost um, 1 to 0 or rightmost 0 to 1. It is very easy. You can take an array, and in that array you can perform this operation. So now let's see how you can calculate the number of inversion pair with order of n time. So suppose you have done the operation, and after the operation the string looks like this. So how you can find out the number of inversion pair present in this with order of n time? So what you have to do, it's very easy. What you have to do, so what are the number of inversion pair for this one? For this one, the number of inversion pairs are the zeros present on the right side of this one. For this one, the number of inversion pairs are the zeros present on the right side of this one. So for each and every one, the number of inversion pairs are nothing but the number of zeros which are present on the right side of that particular one. So you can take a variable C, which is the cumulative sum of the zeros, and initially the number of zeros this c represents, suppose you take a variable c and this c represents number of zeros seen right now. So you start from this index. So you start from this index, you get a 0, so value of c is equal to 1. Then there is, you find a 1, and the number of zeros seen right now is 1. You will also take an answer variable which will be 0, and whenever you see a 1, you just add the c to this answer, so this answer will get 1. Then there is a 0, so the value of c will be 2. Then there is a 1, the value of the c will be 2. Then you see a 1, so the number of zeros seen right now is 2, so you will add 2 this answer. These 2 represents the number of inversion pair. Then you will find another 1, and the number of zeros till seen right now is 2, so the number of inversion pairs this one will make will be 2. Then you will find a 0, so you will now newly c will be 3, because the number of zeros seen right now till now is 3. Then you will find a 1, so you will again add the c to this answer, so there will be 3 added, so the number of inversion pair will be 8. So by this, by taking two variables, one is the indication of the zeros seen till now, and another variable which will get updated whenever you will find a whenever you encounter a 1, answer will be answer plus c. So by doing this loop, you can find out the number of inversion pair in order of n. So to find out the solution, first first uh, first calculate the number of inversion pair without any operation, then change the leftmost 0 into 1, and again calculate the number of inversion pair, and then change the rightmost 1 to 0, and again calculate the number of inversion pair, and the maximum of those three values will get uh, will be the result. Thank you all.